So I know that my hotspot is somewhere over here. So how about having an extra pillar over here or having an extra pillar over here? But after doing that, what I have seen is that the average temperature actually increases. So here you can see it's around 724, but the average temperature increases to 724.99, like a 1 degree increase if I use an extra pillar. And over here it's increased even further, like 8 to 9 degrees more if I have more pillars. So any guesses why this is increasing? Any intuition, any guess? That why if I'm using this more number of pillars, there is an increase in average temperature. Yeah, so that is because there is a reduced airflow. There's a blockage of airflow. That's why the cooling is not able to happen. Okay. There's one more question as to how do I plot my volume average? So there are different ways. So once you have the table over here in the earlier shown example, you can just click on table graph. Okay, then you can see that the average temperature, how it is changing from the with respect to the thickness. The other techniques that we will learn in the post-processing session, uh, but this is a simple way to plot the table graph. Okay, so then finally we have so this actually defeats our purpose. So adding more number of pillars in the hotspot is not the solution. Okay, we can also increase the airflow from the basic 5 centimeter per second to 10 centimeter per second, and you see that after around 6.25 centimeter per second, the temperature of the aluminium heat sink is less than the melting point, right? So you can go ahead with this 6.25 centimeter or more. Okay. So what are the key takeaways from the second example that we have discussed? So all the examples that we have tried is shared with you. So if you want to play around with this, you can play around with this in the model file that we have shared with you. We have discussed 3 to 4 options such as extension of pillar height, parametrically sweeping the airflow, increasing the number of pillars. So all of this have been tried out and shared the models with you. You can also try it out with excellent solutions as we have discussed, as having fin kind of a system, fins having a more like a protrusion of the fins, as more in the bottom, as it goes above it's less. Okay, it's thinner. So those things can also be performed. Okay, so what are the conclusions? So we tried to model a system which is multi-physics with fluid dynamics and heat transfer. We predicted the engineering issues such as hotspots in this case. We tried to understand different parameters which can be used to overcome this engineering issue, such as uh, geometric parameters, uh, physical parameters. Okay, and then we tried to understand the scope of the working of the system. So here it is more about the melting point, that is the threshold that we use to define the scope of the system. You can also verify system using analytical expression if you have those, or experimental results if you don't have analytical expression. Okay. So there is an assignment for this. I will just show you the assignment part and the CLC videos which are recommended before you start for the second session. Okay. So what I will do is I will just open the assignment. Okay. So the link is already given to you over here. Yeah, so we will be able to finish this session in 5 minutes or so. Yeah.